Hello, Dwayne.
How are you doing?
Good man. You?
Good, good. I was on mute for just a second there, but I can hear everything now.
Okay, so we are online again and we can start right now. So I want to say also hello to everyone to join our online event. Let me also introduce myself. I'm Evren, co-founder of Turkey Java community, and we have a very special guest today, Dwayne from Git Kraken. He is working as a developer evangelist at Git Kraken, and now today he is going to make a speech talk about Git. It's a very, let me say, important tool, especially for developers when we are collaborating, working together. Version systems are really important for us. And now let me give the stage to Dwayne. The mic is on your side, Dwayne. You can start your awesome talk about Git beyond just committing. And
Awesome.
thank you again for accepting our offer and welcome again.
Oh, thank you very much. I am very, very excited to be here. I love the Java community. I'll get to that as I start my slides here as those get going. But just thank you so much for the opportunity to come and talk to you today. So I think with that we can get my slides up and we can get going.
Let's start doing. Let the show begin, and you can just start with the slides. Thank you, man, again.
Awesome. Thank you very much again. So we're here to talk about Git beyond just committing. So I'm Dwayne, as I was introduced. I am a developer evangelist here at Git Kraken. I live in Chicago, Illinois. Slightly different time zone than most of y'all. It's morning for me still. Fun fact, long before I worked here at Git Kraken, I worked for a company called Terracotta. If we were in a room live with everyone, I would love to see all your faces. I'd ask you to raise hands if you ever heard of Terracotta. We were one of the first companies that ever talked about distributed caching. I can see people raise their hand through YouTube. That's pretty awesome. I love StreamYard. But yeah, my first real tech job was at Terracotta, like helping people figure stuff out. At one point, not today, but at one point, I could tell you the general Bootstrap class loader path, what order they loaded in. I was pretty deep in the JVM and bytecode manipulation back then. Not today. Don't ask me any questions about that stuff today. Today we're going to talk about Git. But why are we talking about Git at a Java meetup in the Java community? Well, Java predates Git by about 10 years. James Gosling introduced Java back in about 1995, and Git started in 2005. So with that decade separation, there's a lot of projects started, a lot of projects shared out there in a lot of different ways. Think Perforce, think SVN. Fisheye was the first tool I ever used to look at a repo in my modern tech life. So not everybody's using Git, and the people that have been exposed to Git generally are just exposed to the very bare bones minimum commands they need. It's easy to memorize those commands, but it's really hard to conceptualize what they do and what they're all about all the time. It's kind of like explaining to someone how to fly an airplane and having them do very specific hand motions without actually putting them into a real plane sometimes is what it feels like to me. But I think we can resolve that, get into the airplane a bit by digging into what Git actually does and how it stores things. And we're going to look at that a little bit today. A lot of the problem with understanding Git really comes down to the fact that it's conceptual at a level that most people don't live at day to day. I like to think of the imaginary number I in math as a nice analogy. I is very important to how quantum physics works. It's very important to how modern math works. But for thousands of years, it didn't exist. No one could conceive of it because it wasn't directly a physical object you could put in a line or rearrange. And that's how geometry worked up until like the 1600s. But once we introduced that concepts and they were understood, people like Schrodinger and took it and applied it to physics, and we have modern physics. So once you grok the concept of some of these concepts, it's a lot easier to understand how Git works overall. And that's what I want to do today. I want to leave you with a slightly better understanding, at least push you down the road a little bit toward exploring on your own, a little bit deeper, how all of this stuff works under the covers. So what we're specifically going to talk today about is we're going to start with a real quick recap, not of Git add, Git commit, the staging. Those talks exist. There's a lot of them. I've given a lot of those. That's not what we're going to do today, but we're going to look a little bit about the history and conceptual ideas of what Git does, at least from my point of view. We're going to peek into the Git folder and see what's there. Most people are telling me that they haven't done that. So I think it's worth the time to spend a little bit of a cycle to go in there and look. And then we're going to look at some individual concepts and the application of these commands or ideas to our work. And if there's time, we'll get to Git bisect, which I'm not sure we will, but I'm going to try to get through all of this in the next 35 minutes or so. And then we'll open it up for questions. But before we get to that, I want to explain very quickly what tools I'm using. As I mentioned, I work for a company called GitKraken. We make legendary Git tools. As of today, we just relaunched our site as of this recording. And now you'll see that we make not only the GitKraken client, but also GitLens, which is the number one IDE, number one integration for VS Code for extending Git powers there, and Git integration for Jira. You're not going to see Git integration for Jira today, but you will end up seeing VS Code and then therefore GitLens, because I've been a GitLens user for a while now. The GitKraken client, I'm not here to sell you on it. I'm just explaining what I'm using. I like it because we have a GUI in there, and it's a lot easier to do things visually with a GUI. It just is. I can only hold so many concepts in my head at one time. Just visualizing them out into a GUI helps me personally do my work a little bit better and a little faster without having to sit there and think about how a concept works. I can just right mouse click and do a thing. But there's also a CLI. There are times where a CLI is just handy, and some people really love a CLI, especially if you're doing things that you repeat. Just being able to hit push up and modify a commit message just a little tiny bit. That's super helpful. I did that quite a bit when making this presentation today. One of our goals at GitKraken, and specifically with the GitKraken client, is we want to make it easier to use the tools that Git provides without having to memorize a laundry list of commands or go really dig into a concept to like deeply understand it before you can start using it. Just onboard you quickly, make it safe to use, because we have an undo button, and there's a lot of things where you can just say, oops, undo, and you're right back to where you were. And it's just a safety that you're not misunderstanding a concept when you're doing something and putting in a wrong flag somewhere and later having something blow up on you. And there's a lot of power to Git. That's what I want you to walk away with today, understanding some of the superpowers that Git really gives you. Having a client like GitKraken can give you a shortcut into accessing those superpowers. You're also going to see VS Code, like I mentioned. I'm using Java. I downloaded and installed Java this week for the first time in a while. Very happy about that. Brought back a lot of fond memories and made me itchy to start messing around again. And just a really fun example app that I started playing with is just Breakout. You see, it doesn't exactly work right because I started modifying it to give it a hard mode, but not really here to play Breakout in front of you. I made a fork of that in case you want to go grab it. There's that link. Or just look up Java game Brick Breaker and you'll find it. So what we're covering today, again, conceptual recap, peek into the folder and those commands. Let's start out with that conceptual recap of Git and a few historical notes along the way. So Git is a version control system, a source control management system that takes snapshots of your work over time. There's no one true canonical, this is the absolute truest version of a snapshot. There's ones that Git is pointed to by default, But that's all it's doing is at this point in time, I'm taking this snapshot and I've changed these files. And then I've made another commit, and that's a snapshot. Those units of those snapshots, or what get originally called check-ins, we call commits. So every time you make a commit, that informs Git that, hey, you need to pay attention to this. This is something we need to track. Git also stacks those one on top of another, turns it into a graph. I like those pictures of rocks because all of our commits look a little bit different, and it'd be nice if they were all completely uniform. But at the end of the day, let me jump to a more complex repo here. They all start with that initial commit, and then things get a little crazy as we start stacking them. This is the support site for Git Kraken, by the way, but you can see all we're doing is stacking these commits one on top of another, or putting them in different branches, or doing other things with them. But eventually we end up with just this big old graph that just keeps building and building and building. Git gives us a way to modify those stacks of commits, or that graph, as we see fit. That's where it starts getting complicated, because if it's just git add, git commit, move on to the next thing, git add, git commit, and you're stacking 1, 2, 3, 4, pretty straightforward. Once we want to start moving things around, that's a little bit weird. And the ability to take snapshots or get at any of those snapshots and get any of our old work, again, is also weird. Git introduces concepts, like I mentioned earlier with I and math, that don't really exist. We don't have time machines. We don't have the ability to branch off and make multiple realities. Thank goodness the Marvel Cinematic Universe is introducing the multiverse concept, because it'll make it a little more mainstream and hopefully eventually help people understand Git, believe it or not. But the ideas that are in Git that make it so powerful don't really have hands-on like analogies like we have in geometry versus calculus. And unless you're Linus Torvald, who specifically said in his original email, Git wasn't supposed to be a source control management system. Unless you're Linus, you probably don't understand the why or the how of some of the stuff that Git does. He does. Gitster does. Junio and the other people that work on the project do. But most people don't spend their time sitting around thinking about Git internals. And your use case probably isn't there. So it's okay if you find it frustrating. If you walk away today and say, wow, I don't really understand everything that was said, that's cool. You're not alone. Nobody's born learning or knowing Git, unless you're Linus, you didn't invent it. But don't give up. You are not alone out there. Just keep trying, keep at it. There are all sorts of resources. Dang it, Git is a really good resource. If you ever get stuck and you're like, I don't know what's going on anymore, it will guide you through. And there's nothing wrong with, if you get to a point of just pure frustration, blowing out a repo, recloning it down, and starting over again. I'm here to tell you that's okay. You're not a bad person for doing that. That's how getting out of trouble for a lot of things that way. Before I move on, there is one concept that is confusing, very confusing, especially as you're starting, but is ultra important for understanding how Git does its work. Everything is local in Git. Everything. And not just local on your machine or local on a distant machine that you don't own, like GitHub or GitLab provides, but from the point of view of where you are in a repository, you're always local from its point of view. So there's below it is a picture of Oakland, California. I used to live about 2 miles from where these signs are, but Gertrude Stein, who was an artist from the early part of the 20th century, lived in Paris, all over the world, really. But she said, Oakland, the problem with Oakland is there's no there. And so somebody, as a joke in the 70s, made these 2 signs. So there would be a there and a here where you could see the there from in Oakland. Everything is local. So no matter where you're standing in this picture, you are here to you locally. So we are here on the outside of this picture, looking in and seeing here and there, which are both there. even though one says here. And you can be standing at there, and for you, you will be here at there, looking at here, which is there. That's very confusing. But so is Git. But that central concept of you're always here locally, and no matter what it's called, is there from you locally, is a very important idea. I know that's confusing, but it will make more sense as we move through, I hope. And the more you think on it, the more confusing it gets. So let's take a quick peek into the Git folder, which is our ultimate source of truth, which will always tell us where here is from our perspective with Git. And that's the inside of a Git folder. And let's move on. I'm just kidding. Couldn't resist that joke. Let's dig into the Git folder just a little bit and see what's in there. If you're like most people, you probably haven't dug in there. Unlike a lot of things you can break on your computer, you really can't break Git because we're interacting with instances of Git folders and Git repositories. Unless you're specifically digging in the source code for Git, you're not going to be able to break Git itself. You might break a folder, you might break a repo. If you're doing it on a sample repo like I am, it's not a big deal. I can blow this up and no one's going to be mad at me. This isn't production, even though I have a production branch. So here's my Git folder. You can see all of these fun named things. If you've never done this before, play along at home. This is actually super fun to understand. So head, always in capital letters, simply says, hey, Git, this is the place we're looking at right now. This is what our reality is. This is where here is for us. This is the reference that's most important to us. So right now it's pointing out QA pre-staging because that is the branch I have checked out in my repo. Again, I like visual tools. I don't have to do a Git status or a Git log or a Git branch to know where I am. I can just simply see it right here. So yep, I am there. I'm gonna go check out my main branch. And now I see I checked it out. And hey, Git has flipped it head to main. And I'm going to flip it to my dev branch. And now it's pointed to dev. This is another one of those fun real world concept or the areas where there's not a real world analogy I can describe this as. Git simply controls reality. When you repoint head at something else, that something else now becomes here and the reality of now. It's fun. If you've never looked at your head folder while you're moving stuff around, do it. It's kind of cool. Index. Index is a terrifying file when you first look at it because, like, what the heck? It's a binary file. It's a binary file that, let's wrap. A binary file that contains path names and permissions and SHAs, and really controls what Git's doing. Don't mess with the index file, but yeah, it is what it is. We know what it is now. Fetch head, it says where we could, if we fetched from somewhere, this is where we're going to fetch for master. That's where I originally got this. I changed the name of master to main for modern reference purposes. Package references. You see the SHA, the SHA, the hash for each of my branches that I have here. Original head or origin head. Every time you do something risky, what Git terms risky, there's a bunch of commands. I'm not going to get into the details of that. It will build you this little file that says, hey, this is the last safe space. This is the last time I knew it worked before we did this weird thing. Then you have your local config. This is not your global Git config. This is your local config. Every Git folder can do its own config. Hooks folder, which we'll talk about much later in today's talk. Info folder, which tells Git, some pretty specific info. Originally, before Git ignore, this was how you ignored things. Told Git to ignore things. A logs folder, which keeps track of everything that's been going on. Everything that's been going on. We'll take a look at that a little bit later. So don't want to scare anybody with that right now. Your objects folder, which is all of the blobs, the binary logged objects that exist in your Git repo. So everything you do becomes one of these blobs. They're all in binary, so don't worry about reading them or hashing through it. Then you have your references folder that points to, well, where things currently are. Where are the references to these things? All of these are just SHAs. These are the, if I did a git log, you'll start seeing it's the same commit SHAs throughout, but we're not gonna do that now. All right, so that is a quick look. Head just simply points, there's nothing terrifying here, and that's the whole point of why I did this. Go in and take a look around, play with it. Once you understand, like, oh, that's all it's doing, a detached head state isn't terrifying anymore because it just means head is pointing to something that's not connected to the last commit on the graph anymore. Head's just pointed somewhere else other than the very top of the graph. That's all that means. It's just pointing somewhere else. So it's not terrifying. It's just a little confusing. All right, so let's start looking at these concepts in the last 20 minutes or so I have for this talk, and then we'll move on to Q&A. So I'm going to be jumping around a lot more. I know I've been jumping around already, but I'll be jumping around more, and just want to make you aware of that. And if you feel motion sickness or whatnot, it's okay to look away for a bit and just look back up in a minute. So Git squash. Something a lot of times you'll just hear casually thrown around by more senior devs is go ahead and just squash those commits. Squash is simply taking a bunch of commits and pushing them down into one thing, taking all of the various bowls and dumping them into one bowl and saying, that's my commit. This is super handy if you are making a lot of small micro commits. I do that all the time, where I'll be working with something. Commit early, commit often is what I was taught. And at the end of the day, before I push that up to my repo or start a pull request, I'm like, well, I have 13 commits against a README file because I fix typo after typo because, well, I make a lot of typos. Squash gets you one commit, so nobody knows how many commits you actually made. So if I check out my pre-staging branch here, I have a bunch of README changes. I can simply highlight them all and say, hey, get cracking. Go ahead and squash all of these 4 commits for me. And now, just like magic, I have one commit. I simply README change. If I click into it, it's, my README changes. All of my messages from earlier are all still in there. I have written very terrible commit messages. This is not a lesson on writing good commit messages. Do not take this as advice. But here we just saw what squash did. So if I tried that again, if I go like my recolor branch and I want to squash all of these, I'm gonna do this over in the terminal. So I click my terminal tab. It's gonna open that same repo in a new Gitkraken CLI, or the terminal tab as we call them here in Gitkraken. And I'm gonna try that again. So I'm already checked on that branch. We're gonna quick git status. I'm on a recolor branch, that's right. I can see it down here. One of the other really reasons I like Gitkraken as a user, I can always visually see what I'm doing. But I try git squash, and yeah, squash isn't a command. That's another one of those confusing things with Git. And I started it with it because it's confusing, and you'll get told like, hey, just do that with Git or just do that with Git. And the person who told you that understands that squash wasn't its own command or isn't its own command, but no one's going to sit you down and just explain that. You're going to learn it the way they did, trial and error and figuring out along the way. And that's okay. it's all right to be frustrated and say like, wait, that I don't understand this. To back up and say, look, Git's a whole realm of computer science and information technology. What do I need to know to understand what that means? Well, since squash is its own command, understand that it's a function of Git rebase, which is one of the more challenging things beginners say scares them about Git. It's really not that terrifying. One of the ways Git keeps track of what's going on in the world is it knows where the top of the commit or top of that graph is, and it knows where the base of that graph is. What's the first commit that we based this other commit off of? In this instance, this commit here is based on this commit here and all the way up the line. And if it's in a straight line, again, if you're just stacking one thing on top of another in your main branch, that's not complicated. That's just straightforward going forward in time. But you have feature branches or other branches, well, those start basing off of whatever commit you started with. And you can have as many feature branches based off of this as you want. That's where you get those really terrifying graphs that are like a mile wide that have hundreds of branches off of multiple commits. And that's where visual tools really come in handy as well. But a rebase simply lets us pick up that entire branch and move it on top of another specified commit. Most often, this is done on the very tippy top of the graph. So at the end of it, you end up with a nice clean line. And you don't have two branches. You have one timeline that has two branches associated with it. Branches don't work like a lot of people think they work. And something I'm not really going to cover today too much, but branches are just sets of references that start with a commit and have their own top of commit, or their own top commit. It's just a set of references. It's not really a parallel universe. That really wouldn't work on a computer unless you have maybe a quantum computer going. But it's just a set of references and how those are organized and laid out in this graphical theory. Well, to see that in action, let's go back to here. Now, this is one of those things that I can't undo once I do it. So hopefully I have enough branches that this will make sense. So here we have recolor branch, and I have another branch that started here, pre-production. So pre-production is based on my main branch. It started on this node. Let's say I want to take my recolor branch and move it on top of my README branch. Well, I'm just going to drag it up there and say, all right, I want to rebase this on top of there. Uh-oh, I got merge conflicts. Merge conflicts happen. It's fine. Don't worry about it. It can be terrifying, but and again, this is another not sales pitch for Gitkraken. I can open it up and say, all right, I see what I need to do. If you don't use a merge tool like this, Git still is there for you. It's simply going to insert logic or insert text that says, hey, here's what head sees. This is when you started this. Head pointed to this reality. The commit that you wanted to bring in points to this reality. You tell me, computer science person, which is correct. And if you don't have a merge tool like this, you just have to manually edit and then make a new commit. Here, I can simply say, A is the one I wanted, go Java, go open source, hit save, and now I'm ready to make a new commit. Post. I'm just going to skip the commit for now. All right. You know what? Again, nothing wrong here. I'm just going to abort the entire rebase. Sometimes things go wrong and you're like, well, I need to back out of that. One of the terrifying parts about using the CLI for this is, thank you for that note, Mustafa. Yes, absolutely. It's fine to be nervous about these things. But one of the cool things is you can, in the middle of a commit or middle of a rebase, say, you know what? Change my mind. Something's gone wrong. I need to figure that out. Let's just go ahead and abort the rebase. Now that command exists. You can do git rebase abort, and it will do the same thing. But unless you know that flag is there, unless you sat down and memorized it, you might not know what to do. And you're like, well, I'm stuck in this rebase now. And that's the rebase hell, excuse the language, that a lot of people find themselves in. Now they got to go Stack Overflow and start looking around like, what do I do? What do I do? What do I do? What does empty even do? And you start going down a rabbit hole. It just means Git got confused. Git, again, is the stupid content tracker. If we just do git man, or I'm sorry, man git, that's the specific thing that Linus called it. It's a stupid content tracker. It gets confused quite often. And it's not you, it's Git. Git just doesn't know what to do sometimes. But having tools on your side that point out, how to do that. But anyway, conceptually, that's what we wanted to do. We wanted to move from here to there, had some conflicts, but we're not even going to worry about that today. We're just going to move right along, if that's okay, for sake of time. This isn't a rebase class. That's just, if you understand this, like you're trying to move branch onto the top of another part of the graph, rebasing what the first commit in that branch points to, that's all a rebase is. Now, how you successfully do that or unsuccessfully do that is going to matter on what you're doing. This is a weird repo that I've been building for the last day or two. Well, really the last 12 hours. So I'm not surprised that didn't work. I wonder if I do. Anyway, next up, cherry pick. Cherry pick, a little bit simpler to understand and not as scary. We're simply going to pull a commit from one branch and stick it on another branch. Pretty straightforward. Now, if you do this from the command line, cherry pick, git cherry pick, help. You have to specifically parse what the heck they were talking about in their heads when they made this. Is it possible? Absolutely. That's very straightforward, apparently. You just got to say, all right, this is specify where head is and specify where you're going, parent number and that good stuff. This is another reason I personally like a GUI. So I wanted to take a commit from my README change and put it on top of a color branch. I'm going to cherry pick this commit. You want to immediately commit the changes? Yeah, let's go ahead and do it. Hey, I got to commit another issue here with my commits. Well, not a problem again. Here I'm going to say A wins. I'm going to save, and I'm done. Now I've taken that commit from here and moved it over here, even resolved a merge conflict along the way. Nothing really to be scared of. Again, Git's going to get confused along the way. It's like, hey, you're telling me you changed the same file 2 different ways. What do you want me to do? You just got to tell it what to do. And it's that simple. It can be a little confusing, but just know that you have complete control over the graph. You can tell Git, all right, I want them in this order or this order. The ramifications of that is sometimes Git's just going to get confused on you and not know what you mean. But that's what merge conflicts are for. Our merge conflict tools are for. And if you've blown things up and be like, all right, I am really lost. I am not sure how to get back from this state that I got in. You can say, hey, Git, I need to see everything I did, every commit I made, any changes to commits I made in the last 30 days. By default, it just says the last 30 days. That's why we looked at the folder earlier. The Git logs folder. Logs is exactly what it sounds like. You have the ability to keep track of everything you did. This isn't terrifying. I mean, the first time you open this is like, wow, there's so much here. Really not. There is the starting commit and the commit that you ended up with after you did the thing. So a couple of these didn't have starting commits. that they're based on. There were specific actions, like, well, nothing there. Starting commit, end commit, who did it, what their email address is. There's my personal email address, I guess, for the entire world to see. Feel free to email me if you want. This crazy number, does anybody know what number that number is off the top of their head? And why there might be a -6 behind it? I gave you all the clues earlier because I live in Chicago. Date. Nope. Date. Okay. Yeah. Unix time. That's the epic time right now, epic 0. So that's where I am. So if I do it in -6, it moves it time zone because, well, that's where I am. UTC minus. And then what the commit message was, or what the action was. Now, how we access this without digging through the head folder and how we tell Git to use it is git reflog. And if we go down to the bottom of this, rebase aborting. Check out readme branch. Check out, yes, this is a list, and all reflog is like, well, let's look at that file, which stored everything in the last 30 days based on Unix timestamp, flip it upside down, so it presents me as a user with the top of that list first. You notice all of these have a head at number, how many steps we are away from head 0, which is where head's currently pointing. So if you ever get really, really lost, Git reflog can lead you back out. We're not going to get into the specifically how to apply reflog today. This is meant as an intro to like reflog. This is what it is. That's all it is. And you can go from there. So where's it storing all of these things? Like, what do these actually represent? Well, glad you asked. That's your objects folder. If you open your objects folder, there's a bunch of funky name files in here and a bunch of funky name folders that are mathematically put together. And then you get these two little folders, info and pack. After 30 days, as Git's cleaning itself up, it runs garbage collection. And this is the Java community, so y'all should understand garbage collection really, really well. The JVM GC is an interesting beast. At least it was back when I was working with it. So we got to take out the garbage. The garbage is all of the things on our reflog that Git can no longer see or deal with or are just old, that it can't reach anymore. So if we run that real quick, get out of here, do clear, and we do git GC. Hey, whoa. Our objects folder just shrunk in size dramatically. And it packed it inside of a pack file, along with an index file that says how to unpack the index file, or how to unpack the pack file. It's using zlib, Z-L-I-B, as the compression technology underneath the covers, in case you're interested and want to see a really interesting project that's been around under most people's radar for a very long time. I didn't even find out about it until the last couple of years, but it's been there for forever. And it takes all of those things, packs them down, which means unpack, Control R, unpack. Yeah, it gives us a way to unpack our most recent file and give us access once again to things we just recently packed in. Again, today is not a full demo and deep dive into how to pack and unpack things. Just know that that's what's going on. And the whole point here is no matter what you've done, it didn't lose it. It's still there. If you've made a commit early, commit often, because that commit's still going to be there. It's going to be there for at least the next 30 days. So no matter how much you've broken a repo, no matter what crazy things you've done, and now Git doesn't even recognize any of the files anymore and gets to one of these crazy states, don't worry. You can get back. There is a path back between reflog and Git GC and unpack. You can get there. GC is going to, GC cleans it up, but you can get back from it still. GC is really useful if you're starting to get a very slow repo because it's grown dramatically. Think thousands and thousands of files or millions of files. Git's tracking all of that, all the commits you're making, even though it's just tracking deltas over time in those, in those objects. It's still a lot of them if you have a lot of files. So garbage collection will pack them down, clean things up. Git does it naturally under the covers, but you can control that again. All right, I realize I'm running out of time, looking at the time on the clock. So we might not get to bisect, even though I'm going to still show you the slide. Git Hooks. Git Hooks is a way simpler concept than trying to understand the internal garbage collection and reflog idea. There's a folder that specifically just has a set of files that says, if this happens, trigger something else. You can build your own Rube Goldberg devices. So if we jump back into our file here, close these things down so we don't get confused. We have a hooks folder, and it comes with, by default, a bunch of samples. And if you look at any of these samples, you can say, all right, before a rebase happens, do this thing. This is written in 2006 by Junio, the maintainer of Git these days. It does stuff. If you look at some of these others, though, we start getting to Perl scripts. I say that, and oh yeah, here we go. Bash or Git was written for Linux, assuming you had C, access to C and Perl and Shell on your machine. If you didn't, well, you couldn't use it then. That's why Git for Windows exists. There's a great talk by Johannes Schindelin over on the Git Kraken website these days from a talk he gave at GitCon, which is a conference back in September, that talks specifically about the fact that he didn't have Perl in the latest edition of Python, so he couldn't use Git, so he had to fork everything over. Anyway, my point is these are just scripts. And there's all these weird, like, what is this? How do I parse this? I'm here to tell you, it can do anything. If you can run it from a command line, you can run it from a Git hook. And that's simply how it is. So if I rename this real quick, I'm going to see it. Rename. And take off the word sample. That sample tells Git to ignore it. But as long as it's like pre-commit is a specific step. And I'm not going to get into how Git hooks work. That's not this talk. But there's a bunch. All of these are specific steps that Git has to go through. So there's a pre-commit step before the commit actually happens. And now I'm telling it to run this command. If you don't know this command, it's fun. It just spits back a dad joke if you curl that server. So whereas Napoleon keep his armies and his sleeveys. That's a terrible joke. But now if I go make a change to, I don't know, readme, some random garbage in there and do git add, git add dot, and then clear, do a git commit, can't type, readme change. Now it tells me a dad joke every time. This is based on a project called Git Dad, is where I got the idea. So I escaped there. Yeah, Git Dad by Edward Thompson, the maintainer of NPM these days. But he wrote this little way to make your typos spit out dad jokes. So that's where I got the logic for that. Just a shout out to Edward Thompson real quick. All right. So I am going to pull this train into the station and just say there's a command called git bisect. If you ever find yourself in a situation where, hey, the code works over here and I made some changes and now the code don't work, Git gives you a way to figure out where things went wrong very quickly by cutting the graph in half between the time you say This is where it's good and this is where it's bad. Not going to show it today just for sake of time, but this is a great one to go look up on your own. So if you have 30 commits, it says, all right, between the 30 commits, it doesn't work here, it works there. That's cut in half. Now we're halfway down and we have 15 commits. Does it work at this base? It still works. All right, let's cut that in half. Now we're at 7 and it still works. Let's cut it at 3. Okay, it doesn't work here again. So it must be between 3 and 7. And now you know where to look and find your good state again. So that's it. There wasn't really enough time to cover the last couple in detail because we're out of time. This is only an hour. But I just want to say really special shout out to Evertan for inviting me to give a talk here. He's one of the legendary GitKraken ambassadors. That's a program that I help run here at GitKraken. Thank you very much for the invite. If you said, hey, that GitKraken thing looked like it'd be helpful, go ahead and use his link there, gitkraken.link/Everin, and you can download your own copy of GitKraken today. Get the GitKraken client today and get running. So with that, I'm going to say thank you very much, and I will open up for questions. And sorry I went so dang long.
Dwayne, thank you, by the way, for this great presentation. And I really like, by the way, the examples that you gave for the fundamental of Git, especially for the Git folder, had originate, config, how we are using them, how they are impacted while we are using the Git commands. And thank you for this great presentation. There are 1-2 questions, let me say. One of them is related to the famous one, the difference between Git merge and Git rebase, of course. So
Sure.
there is a question related when we have to use Git merge or when we have to choose Git rebase instead of Git merge. It's one of the questions. And by the way, there are 2-3 questions related to this difference between Git rebase and Git merge.
Absolutely. This comes down to what you prefer, believe it or not. There's no 100% true right with this. And that's one of the annoying things about a lot of answers in Git. It depends. Let's jump over to my editor real quick. See, I want to merge. Let's merge this into here real quick. So I'm going to merge. I'm just going to resolve them all. Cool. See how there's this line in my graph that still says, hey, this branch still exists over here, but now I've pushed the top of that commit branch into another branch. So now the head here points over here. This will stay true for the end of time. If you only have a few branches or you have a good strategy to clean up your branches behind you, like always delete branches if they're not being used, commit work great, and your branch and your graph never gets too crazy. Let me open open repo Git. I don't have it. Yeah, I do have it. Nope, I don't have it loaded. I thought I had the Git repo loaded locally. But if you look at a very large repo that's existed for a long time, this is a good example too. This is a pretty wide graph at certain points. Just understanding long-running branches and like how complex your graph gets is annoying after a point. Some organizations, some teams prefer, I'm going to move my branch onto the top of another existing branch. And then that side branch no longer exists because now it's rebased onto the same branch and you have that nice straight line on your tree. Some people find that cleaner. Some people find it better. There's no 100% true, this is the right time to use it. It's a matter of preference for how you like to keep your long-running branches around and maintain the repo.
Thanks, Steven, for the explanation. And also there is one more question related to Git Kraken. What is the motivation after the Git Kraken? And also they are asking the stack and the language that you developed Git Kraken.
That's an interesting question. So the last part first, the stack for Git Kraken is an Electron app. So what you're looking at here is Electron. So this is Node at the end of the day. Because it's Node, and this is a fun, interesting fact, it's actually a really important fact. How we have an undo button is because we don't implement the Git CLI directly under the covers. We're not using the Git SCM software in C as it is when you download it for the CLI on your computer. We use a project called NodeGit, which itself is a port of libgit2. Libgit2, go shut it real quick, is a project that gives you all libgit2, gives you all of the core methods of Git without implementing the CLI. So with the CLI, it parses everything to text for human readable screens. If you were think like GitHub, GitLab, like all the providers, like they're not parsing text output into their own format. They're simply implementing the core methods, because at the end of the day, Git's just manipulating file systems. That's really all it's doing. There's no real magic to it. It's just a complex way to approach it. But that's the underlying tech of Git Kraken. So the first part of that question was beyond Git. Well, I'm sorry. Could you repeat the first part of that? I got lost in the tech stack. What technology stack and programming language do you use while developing Git Kraken? Oh yeah, so it's Node, Node on Electron.
Thanks, Dwayne. I think these are all. We don't have any question, and thanks for the presentation again. And also, I just want to invite my friends to take a photo for this great event. And thanks everyone for joining us for today evening or today for this great event with Dwayne. And see you in our next event also. Dwayne, just stay online. We are just going to take a photo for this great event.
For sure.
Okay? And thank you, everyone.
Well, thank you, everyone. It was great to be here. Oh, so I did see one other question before we jump off that was about rules for commit messages. So it was back a while. There's no right answer to that, unfortunately. That's another one of those it depends. Talk to your team and find out what's going to be the most helpful for your team and your project long term. And if you do find that there is a common way that you need to write commit messages, Git Hooks is there for you. You can make it write commit messages for you. It's a little bit of parsing with Bash, but you can totally do this. So I encourage you to look into your Git Hooks folder and make it your own, and make your own crazy Rube Goldberg contraptions of your workflows.
Dwayne, thanks for the last minute answer also.
Okay.
So thank you guys. Thank you everyone for being with us today. And again, thank you Dwayne for this great presentation, and see you in our next event.
Yeah, absolutely. Thanks so much for letting me be here and for presenting. So thanks, and everyone for being here.
Yeah. Dwayne, just stay online for the photo, okay? A little bit.
Will do.
Have a nice day, everyone.